Meet Jay. Jay has always been the life of the party. One afternoon, Jay and his friends headed over to the beach. After they were in the water for about 20 minutes, Jay's friend suddenly ran out of the water laughing and shrieking in disgust. It seems that Jay urinated in the water at the beach. How disgusting. After teasing Jay and talking for a while, we began to think, if rainwater comes from the evaporated water from the earth, then would Jay's urine be included as a part of the precipitation? To explore this question, we talked to a few people on the street.
You know, like if you throw like one of those 6-pack plastic things into the ocean, it just like stays together and it kind of disappears somewhere. You don't see it anymore. Clears your conscience. So probably what happens is like just like that, the urine kind of stays together because it's not with the water, and then it goes through and it comes up with the rest of the water, however it gets into the clouds, and then comes down also together in the same area. So maybe like some areas have more urine concentration than other areas.
Well, I believe that water and a certain set of other chemicals evaporate. I don't know exactly what's in urine, but I know the water in urine would evaporate and certain other parts of urine would not, so I wouldn't say urine as a whole.
Does the urine come back as rain? Of course it comes back as rain. I mean, I was just out yesterday and it was raining and you could almost taste it. It was disgusting. I had to get an umbrella. You just had to watch out when it's raining, is all I have to say.
No, the rain will not include the urine from Jay, because since the water evaporates and when it goes into the clouds, evaporation is a form of heat towards the water. Heat normally removes it, like bacteria from things. So therefore, all the bacteria in the water that is the urine will be removed when it evaporates. And then when it comes back down, it's pure again.
So the urine actually won't evaporate and won't go up in the rainwater, because actually no ocean water evaporates. Actually, ocean water isn't part of the water cycle. And the reason why is because the ocean water is so compact and condensed together. It's kind of like when you have snow in a group, it's not going to melt if it's condensed together and packed together. You've got a large group of snow. But if you take snow separately and put it in a small container, then it can melt. The rest of the snow isn't there to keep it warm, to keep it cold. So, like the ocean water, and anything in the ocean water, it's not going to evaporate because there's so much other water there keeping it moving and stopping it from actually being heated and condensed and go up into the water cycle.
There are 4 critical ideas we need to understand Jay's situation. First, water changes from gas to liquid. Second, water changes from liquid to gas. Third, water comes back as rain. But let's start by understanding how water changes from liquid to gas. Many substances change forms from liquid to gas. Water forms gas in the air is the exact opposite of what happens when water disappears when it turns from liquid to gas. There are a few ways that this happens. First, when water in the air begins to cool quickly, this water will then start to bump into each other and form bonds until it becomes liquid again. Second, when water in its gas form begins pressed together in small spaces, it will begin to form water, like on the mirror in the bathroom. Natural examples of this include dew, fog, mist, and clouds. They are all the result of water changing from its vapor form back to liquid. The formation of dew provides a good example of what happens when there's dramatic changes in temperature. It happens because the water molecules in gas form are bumping around, but because of a change in temperature, they begin to bump more often as they move slower and form bonds until they become liquid. This is what happens on cold mornings. Another way that this happens is if they're suddenly pressed together in a small space. This is what happens in bathrooms. Scientists call this process condensation. Water can also change from liquid form back to gas form. If you spill a teaspoon of water on the table, if you come back a few hours later, the water will be gone. It is changed from its liquid form back to its gas form. This occurs because tiny pieces of water are always moving around in random directions. If these tiny pieces of water begin to move around fast enough, sometimes they can gain enough energy that they will cause the water to change its structure. It can make the tiny pieces of water move just fast enough that it can change into its gas form. We can't see this happening, but we can certainly feel it. Examples of this are steam and humidity. If the water begins to gain enough speed, it'll change its form and change from liquid back to gas. This process will continue to happen until all of the water has disappeared. This process of water changing from liquid to gas is called evaporation. Clouds are just clumps of water and gas form. They form because water in the gas is trapped because of the changes in temperature, or because they begin to stick together because a lot of water in the gas form is compressed in the air. These droplets are way too small to fall as rain, but they are large enough that you can see them as a cloud. Water is continually changing from gas to liquid in the sky. If you look closely at the cloud, you can see some parts of the clouds disappearing and forming again in the sky. Most of the water molecules in the cloud do not fall as rain because their speed is not fast enough to hold up against the wind that pushed the clouds up in the air. For rain to occur, first, the tiny pieces of water must form around a piece of dust, salt, or smoke in the air. These tiny particles act like centerpieces that allow the water and gas form to clump around the particles and form water in liquid form. Now, the water droplets may grow large enough to bump into each other and to gain extra size. If the collisions happen enough, water will be big enough to resist the wind speed of the upward air, and then water can fall in its liquid form as rain. This is difficult because for this to happen, we need millions of little water molecules forming to form a single raindrop. This process is called precipitation. The water cycle is the explanation of how water circulates from land and back to the sky and back to the ground again. The sun's heat provides enough energy to speed up water and makes water change from its liquid form back to its gas form. Once this happens, water from the oceans, rivers, and lakes will change form and begin to head towards the sky in gas form. Plants will also lose water into the air. The water in vapor form eventually slows down by cooling, and it is pressed together to form air in the clouds. When the clouds meet with cool air over land, rain begins to fall, sleet sometimes, and snow if it's cold enough. Water will eventually run back to the sea. Some of the rain will get soaked into the ground, and some of the underground water will be trapped under the rocks or clay and provide pools of water underground. But most of our water will flow downhill and eventually return to the sea as slightly salty water. The entire process of water changing from liquid to gas and then coming back in the air is called the water cycle.
When we watch the weather report, we are watching a simple report of the hydrological cycle. The reporter tracks the movement of hot air masses and cold air masses. The weather reporter knows that when these two types of air masses intersect, the immediate product will be an intense condensation process and ultimately the precipitation of water molecules. So as we watch the weather report, we're actually documenting segments of the water cycle. Although the reporter does not provide reports of evaporation, when the report is of sunny days, they are essentially offering a report of the evaporation index. So now let's return to the scene of the crime. So given that what we've learned about the hydrological cycle, what can we say about Jay and the case of urinating in the beach? Would the rain include his urine? That's a question that only you can answer.